Hi, I'm Mark Trexler. I'm Director of Climate Risk for DNV, and welcome to this series of webinars on climate risk as knowledge management. Climate risk is a very complicated subject, more and more information available literally almost every day, which is why I've started thinking of it more and more as a knowledge management challenge for companies around the world. And this series of webinars is an outgrowth of that conclusion. DNV is a risk management firm. We're in 300 countries around the world with 9,000 employees working in all areas of risk management. I hope you enjoy the webinar. What I'm talking about today is maritime black carbon. This is following up on a shorter talk that I'd given, and I'd promised to post a longer discussion of the subject on the web for people who might be interested. And what I'm going to be sort of getting at is the question of why policy seems quite likely when it comes to maritime black carbon. And at the same time, why is it such a complicated subject for us to be grappling with? So let me take a quick look at my executive summary, because I think this sort of lays out pretty well what I'm covering, although I'll be doing it in a lot more detail after the executive summary. So first, it's really important to understand the policy and regulatory context and the fact that they're much bigger than the issue of maritime black carbon. It's not as if people sort of went searching for key solutions to a particular problem and came up with maritime as the key solution. It's a much bigger policy context, and I'll talk about that. And specifically, maritime environmental regulation, which is now seems to be coming fast and furious, is really an extension of long-standing land-based regulatory trends. And second, you can actually see some interesting analogies between where black carbon policy is headed and where coal-fired electricity policy is also headed. Generally speaking, we don't have a lot of regulation against coal-fired electricity, but there is now enough uncertainty about the future of coal-fired electricity that we're seeing more and more reluctance to go down the path, for example, of new coal-fired power plants. And I think we may well start to see something parallel to that in terms of fuels that are producing a lot of black carbon. When you add to the overall regulatory context the fact that maritime emissions are growing rapidly, including black carbon emissions, that makes it a policy priority. When you add the fact that you have real overlapping health and climate change concerns here, you can come at the black carbon issue from a health perspective, you can come at the black carbon issue from a climate change perspective. That really tends to make it a bigger priority. When you add in what's going on in the Arctic today, and the irony that climate change in the Arctic is going to make it possible to see a radical increase in maritime emissions in the Arctic, which in turn is likely to contribute to more climate change in the Arctic, that makes the subject of maritime and black carbon an even bigger priority. That said, things then get complicated. It is a complicated policy setting process, partially because of the relationship between black carbon on the one hand, which is a climate forcing agent, and aerosols on the other hand, which tend to have a negative climate impact. And so you have countervailing forces here that make this difficult. This is definitely a current topic. Outcomes on this issue are far from clear. We won't know for a while exactly where this issue is headed. But I think it's safe to say that the direction of policy is clear, and that it makes sense to be thinking about technology and cost issues, and it makes sense to be thinking about where we're headed in terms of future fuels issues. So let me go ahead and jump in to the slide deck. What I'm going to do is sort of run through a series of different points, basically. As I noted, this is a current issue. I mean, even here, April 2011, here's a headline talking about how the National Oceanic and Atmospheric Administration is joining international efforts to track black carbon in the Arctic. So this is still very much an active scientific issue. There's quite a bit of literature on this. There are a couple of places. Jim Corbett does a lot of work in this area and came out with a well-known article last year specifically looking at technologies for reducing short-lived climate forcers in the Arctic. But there are a number of other interesting reports. The IMO has been coming out with quite a few materials and submissions around black carbon as a result of some of its earlier meetings and investigations into the subject. More and more attention is being paid to the sort of the larger issue of black carbon, not just maritime black carbon, but there is more and more attention around black carbon as a contributor to climate change generally, not just from maritime. So there's a lot of interesting work going on, and I've tried to draw from a bunch of that work in terms of putting together this discussion. So let's start first with the context for black carbon policy. I tend to find it useful to sort of remind us of, not so much in the maritime sector perhaps, but where has environmental policy come from over the years? And this is an interesting chart because it shows sort of in the 60s, 70s, 80s, 90s, just an explosion of environmental regulation. This is in the U.S. The Clean Air Act is in there in the early 70s, and this chart, I've looked for an extension of this chart in terms of something that goes past 1995 and haven't been able to find anything, probably because there's simply too much to try and put into the chart. So it's safe to say that environmental regulation, including air quality regulation, particularly for land-based sources, really has exploded. It's also safe to say that regulators have a lot of confidence in the approach that they've been taking. This is an interesting graphic from the EPA that shows that even while aggregate emissions on the bottom have gone down dramatically, have gone down 60% aggregate air emissions, 60% from 1970 to 2008, population has increased, energy consumption has increased by 50%, vehicle miles traveled have increased by more than 150%, gross domestic product has increased by more than 200%. So it's safe to say that regulators are really quite comfortable with the regulatory approach they've taken to land-based sources, and are quite convinced that the general approach, cost-benefit analysis approach that they've used to establish a lot of these regulations and a lot of these targets has served them well and has served the public well in terms of quite high ratios of benefits to costs. And that is very much the same kind of argument that we are now starting to see applied to maritime regulation when it comes to the new ECAs. And it's very much the same kind of assessment we'll see when it comes to maritime and Arctic emissions and black carbon emissions, particularly because, as we'll also see, the health impacts, the mortality impacts of black carbon, based on the modeling that has been done, is clearly within the realm of where we've seen other regulations come in. So, another context for black carbon policy that's a little bit different from the regulations per se is just what's happening in the Arctic. And we all know that there's a lot happening in the Arctic. Sea ice is shrinking. Sea ice is getting thinner. There's discussion around some of the specifics, but the general trends do appear pretty clear. And this is a source of alarm for many, although for the maritime sector it's a real source of opportunity in terms of opening up shipping routes that have not previously been open. But in a sense, this is being treated as sort of a canary in the coal mine, and so it's certainly part of the broader context for black carbon policy. So let me look for a second at the question of why go after black carbon. Why is there such a significant focus on black carbon as a pollutant, both in terms of health and in terms of climate change? Here we can look at some of the co-benefits of controlling black carbon. You can see on the left there, climate change. Controlling methane and black carbon actually has a pretty significant effect on avoiding temperature increases in 2050. Pretty wide uncertainty, but a very significant number nonetheless. In fact, some people have estimated that black carbon is currently contributing a forcing that's equivalent to about 40% of what carbon dioxide is doing. So black carbon is certainly significant on the climate side. But if you then look at human health, you can see that controlling black carbon is estimated to avoid anywhere between 1 and 4.5 million premature deaths in 2050, which is certainly a significant number. And then when you look at food security, again, a pretty wide uncertainty band, but when you combine methane and black carbon, you're looking at an expected value of 50 million tons of avoided crop losses, but potentially as much as almost 150 million tons. So it's obvious why people are thinking about black carbon as much as they are. You then have the fact that black carbon has been growing dramatically certainly over the course of the last century, and it continues to grow dramatically with transportation sector, fossil fuel combustion, and also biomass burning. So it's a growing forcing mechanism and has gotten quite a bit of attention as a result of that. You can then take a look at the fact that black carbon has a global warming potential, and remember that carbon dioxide has a global warming potential of 1. And so black carbon is estimated to have a global warming potential of somewhere between 700 and 2,000, meaning that a ton of black carbon is equivalent to 700 to 2,000 tons of carbon dioxide. And in the Arctic, where you have sort of the additional variables of affecting the albedo of ice, etc., when black carbon deposits on it, you have a global warming potential that's actually much higher, 3,000 to 7,000, which is quite a high global warming potential. Another reason to think about black carbon, particularly in the context of in the Arctic. But to come back for just a second to some of the climate change, here's a graphic looking at the radiative forcing. Watts per square meter is a key way to think about climate forcing and the contribution of different gases. This is black carbon's radiative forcing from all sources of black carbon. You can see that there is a lot there involving biomass burning and other types of activity, but it's certainly a significant number with 1 to even 2 watts per square meter of forcing over some parts of the world. And then when you look at the projections of increases in summer temperatures out to the 2090s associated with increasing black carbon emission and decreasing sulfate emissions from other controls on coal plants, for example, you have a pretty significant impact. In the U.S., even 2 degrees of the warming anticipated to be linked specifically to black carbon and reduced sulfate. So another reason, another obvious reason that there's a lot of attention being given to black carbon. So there are a whole series of reasons, climate change, public health, that really do explain why there's a push to go after black carbon. Why go after shipping? What is it about shipping? Well, it's easy to go through some statistics here in terms of a lot of shipping is in the northern hemisphere and a lot of shipping is up within the general Arctic boundary in terms of being above 40 degrees north. So there's a lot of shipping activity in the Arctic zone where we're so concerned about ice melt and changes to the Arctic environment. Ocean-going shipping contributes about 900 tons of black carbon in the Arctic zone, but with increases in shipping in the Arctic, especially as we move towards an ice-free Arctic, we're anticipating, some projections are that we could see anywhere between almost a tripling to a five-fold increase by 2030 in black carbon emissions in the Arctic from shipping. So that's a clear reason that there's this focus on shipping's role, even though globally shipping is actually a very modest contributor to black carbon emissions. But in the Arctic, shipping's role is quite a bit more significant. Move to the next subject of specifically black carbon's climate impacts from shipping. First, let's think about there are several different ways that shipping can affect climate change. And this is where the things get complicated because to some extent they're contradictory. So you have a warming effect associated with just the emission of carbon dioxide from the burning of fuel. You have a warming effect from production of ozone, from emissions of NOx, and you have a warming effect from black carbon itself, which as a black substance absorbs heat, changes the albedo of ice, for example, that it deposits on. But then you also have cooling effects because shipping puts out a lot of aerosols in the form of sulfur aerosols, for example, and sulfates, and that tends to cool because sunlight tends to bounce off the aerosols and go back out into space without actually hitting the planet and going to ultraviolet. You have reductions in methane, which is a warming gas. And then you have the whole issue, which gets very difficult and still a lot of uncertainty around it, of how all of this plays into cloud formation and the types of clouds that get formed and their radiative properties, whether they're tending to warm or to cool. So there are a whole series of ways that shipping affects climate change potentially. Then there's one interesting graphic that I wanted to show, which is looking at how will black carbon change the albedo if we see high growth in shipping in the Arctic out to 2030. And as you can see, the change is pretty dramatic in terms of the areas up in the Arctic zone there with the dark colors. So if we see a high growth rate in Arctic shipping, by 2030 we could have, as I mentioned before, radically higher emissions of black carbon and other substances in the Arctic zone, which in turn would have a significant effect on albedo. So it's clear that shipping can have a significant effect, which is one of the reasons to go after shipping. But then let's take a look at health impacts of shipping, because here too it's quite an interesting story. Here's one quote or one study sort of trying to look at the question of premature mortality due specifically to black carbon and particulate emissions in the latitudes 40 degrees north and above, for two different time periods. So if you're looking at cardiopulmonary, best estimate 4,000 rising to 5,800 up to 2,000, significant range there. Lung cancer 300 going to 400, and when you put the two together, obviously a larger estimate and a larger range. But we're talking 5,000, 6,000 premature deaths based on the modeling due specifically to ship emissions north of 40 degrees in latitudes 40 degrees north and above. And that's a significant number. Also, when you convert it to the mortality rate, it's worth noting that a lot of air regulation in terms of land-based sources occurs in if you can demonstrate a greater than 1 in a million chance of premature mortality. That's when you tend to see regulatory regimes being put into place to control that risk. And you have that now from the yellow you can see there on the globe in terms of premature mortality attributed to ship black carbon and particulates. You're in that 1 to 10 range for a pretty significant swath of the northern hemisphere there. And then last, another interesting graphic here taking a look at how is premature mortality from shipping comparing to what's happening in other transportation arenas. And here we have ocean-going ships being the yellow, and as you can see from 2005, 10 to 20, the premature mortality is increasing pretty significantly. At the same time that premature mortality from trucking is coming down dramatically as a result of pollution controls. So with trucking, by 2020, we're talking about shipping and trucking potentially being about equivalent, whereas in 2005, trucking was almost an order of magnitude greater than shipping. And so, when you add to the fact that shipping is increasing dramatically, other sources are being radically reduced through regulation, it's not really a surprise that shipping then becomes a subject of interest for the regulators. If we think about sort of options for mitigating black carbon emissions associated with shipping, there's been some very good work on this recently. Jim Corbett's been doing quite a bit of work on this at the University of Delaware, but there's other work on here as well. Some of the different technologies that people are looking at: diesel particulate filters, emulsified fuels, seawater scrubbing, slide valves, water and fuel emulsification. Each of these different technologies has a cost element, obviously, and an ability to control black carbon emissions. And a bunch of this work has come from the article that I mentioned earlier, Jim Corbett's article in Carbon Management in 2010, which is sort of a key part of the discussion right now. It was reproduced in some of the IMO documents earlier this year. To sort of put a bunch of that together, this is a summary graphic looking at a series of the technologies and basically estimating some of the costs per ton of black carbon, per ton of CO2 equivalent, and looking at it under this question of are you thinking about it over a 20-year horizon or over a 100-year horizon, which is important because, particularly when you're thinking about CO2 versus black carbon, is because black carbon tends to disappear pretty quickly. Black carbon is in and out of the system within a year, much shorter than that actually, whereas CO2, when it's in the atmosphere, is there for centuries. And so with global warming potentials generally, the IPCC tends to use a 100-year global warming potential number for analysis. And black carbon doesn't really fit into that model because it comes and goes so quickly, but while it's here, is in fact a very powerful forcing agent. But there was a nice executive summary here that talked about being able to achieve a significant amount of reductions at the equivalent of $15 to $30 per ton of CO2 equivalent, which is a pretty reasonable number, and that's based on a vessel spending somewhere between 25 and 100% of its time in the sensitive regions. The per ship annual cost of control in the $25,000 to $35,000 range, up to 3 times that for larger ship sizes, and an estimate that to get a 60% black carbon reduction target in the Arctic would cost somewhere between $8 and $50 million per year and avoid somewhere between 9 and 70 million metric tons of CO2 equivalent per year. And so in that sense, quite an effective CO2 mitigation strategy compared to many of the others that are out there. So again, there are a whole series of technologies that can be pursued with existing fuels. Obviously, if one switched fuels, one would have a smaller problem in terms of black carbon emissions, if one went to LNG or something along those lines. But there are certainly options out there. They vary widely in cost. But when you put the different options together, the modeling is suggesting that there's quite a bit that can be done at a relatively reasonable cost, and that's certainly going to be taken into account by policymakers. So why is black carbon so complicated a target? If we know what we're trying to do, and if we know a lot about it, what makes it sort of a catch-22, as I referred to it earlier? Well, there are a number of issues. One is that there's still a lot we don't know, and then there's this issue of the contradictory impacts that I mentioned earlier. So this is an interesting graphic here. If you look at the estimated contribution to warming since 1750 of black carbon containing soot particles, so this isn't just the black carbon, but it's the larger grouping of particles, which then includes aerosols and cooling particles. You'll see it's a bit of a complex picture. You have the soot particles there circled, but you then also have the greenhouse gas emissions, obviously, but then you also have the cooling particles, which is the sulfates and other things that have a net cooling effect. So the net observed warming from the soot particles is much less than what one would have expected if one simply added up the 3 categories. So if you go out and say, okay, we're going to control black carbon in a dramatic way to get rid of its forcing mechanism, if at the same time you end up significantly reducing aerosols and the cooling effects, you could actually engender, at least in the short term, a significant warming that up to this point has been hidden by those aerosols. And that's one of the things that makes this so complicated in terms of how do you regulate this issue, and it's one of the things that makes it quite politically contentious. One interesting way of looking at that is this idea that the radiative forcing of black carbon is equivalent to about 0.2 to 0.9 watts per square meter. But overall, the particulate matter has a cooling effect of 1.3 to 1.4 watts per square meter. So again, if in taking out the black carbon, you also take out the aerosols, you're actually going to see a net increase in warming, at least for some period of time, and that's what makes this quite a complicated subject. Another reason for it being quite complicated is just the very different sources of black carbon depending on where you are. This is an interesting graphic that shows the emissions of black carbon geographically and then by sector. So number one, the amount of black carbon being emitted is radically different by latitude. But then for some latitudes, it's open burning that is creating most of the black carbon, and for other latitudes, open burning is almost entirely irrelevant, and it's industry or fossil fuels or transportation sector. So anytime that you have a very different set of contributors to the emissions that we're talking about, it makes a more complicated situation. But at the end of the day, a key variable here is simply the fact that there's still just a lot that we don't know. And that's why there's still ongoing science in this area. So sources of uncertainty still just emissions factors, the quantification of the different sources of black carbon, the impact on direct radiative forcing, the indirects through the cloud and albedo effects, or the cloud albedo effects, and then the indirect through the snow albedo effects. And so there really is a lot we don't know, and it certainly makes it difficult to know how to go in and build policy and regulate, especially given this internal contradiction that we've talked about of black carbon on the one hand contributing to warming, and on the other hand, since it's so closely associated with aerosols that contribute to cooling, it's a bit of a catch-22 in terms of how do you actually go in and begin to regulate it from a climate change perspective. You obviously don't have that problem from a health perspective. From a health perspective, those two things go together. But from a climate change perspective, you have this internal contradiction. So that's why black carbon is such a complicated target. So to wrap up, where does this likely leave us? If we want to think for a second about forecasting black carbon policy, where do we see it going? Well, as long as we have this Arctic policy driver, I think the pressure for black carbon regulation from Maritime is going to continue to increase. I don't think there's really any doubt about that unless we saw something fundamentally change in the science. So the pressure is going to continue to be there, and especially given how important black carbon is to short-term warming and how significantly you could help reduce near-term warming by going after and doing something about black carbon. The pressure is going to be, from just a pure climate change perspective. Some people are arguing that all of our near-term attention should be focused, for example, on methane and black carbon rather than on CO2, because the bang for the buck is so much greater. So the pressure from a climate change perspective is also, absent some fundamental change in the way that we think about these things, is also going to be quite strong. That said, it's not uncontroversial. This is just a clip from, in fact, a very recent clip, just mentioning that while a number of countries are pushing for black carbon to be included in the list of greenhouse gases under the UN Framework Convention on Climate Change, India and others have staunchly said no. And clearly, that's not because they're particularly concerned about Arctic shipping, but they are concerned about the fact that a huge amount of black carbon is produced in India, for example, from biomass burning and other sources, and therefore they're concerned that if you include black carbon as a pollutant under the Climate Change Convention, it will come back and affect them in a very direct way. So there are a series of reasons why black carbon policy is a challenge from the standpoint of the climate treaty, for example, and that may or may not carry over into the IMO. Obviously, a different set of factors there, but it's not. It will remain contentious, and it's simply not that simple to do. If you look at sort of this hierarchy of what's involved in mitigating black carbon emissions, there are significant implementation barriers to getting all of this put together in a way that has a significant impact, a series of different steps that you have to go through, from international agreements down to local government buy-in, because there are a lot of activities at the end of the day, especially in land-based sources, that are contributing to black carbon emissions. And you need a whole series of inputs there on the right to actually lead to the outcome that we're looking for. So this is not a simple matter, but it is probably relatively simple to think about regulating, from a technology perspective, regulating shipboard emissions. And so this brings us back again to why I think that we will continue to see significant pressure for shipboard regulation, even though ships are a relatively small part of global black carbon emissions, but there's enough of an interest in the Arctic situation, and ships are a big enough contributor in the Arctic and potentially a much bigger contributor over time that I think we'll continue to see the kind of pressure that I've talked about before. So thank you very much. Please let me know if you have questions or feedback. I would welcome it. So I wanted to give just a very quick introduction to the climate risk brain, which I've been using for the webinar, as you've seen. The idea here is that there is so much information floating around out there on climate change, climate risk, climate opportunities, that I really do see it as, for companies at least, as a knowledge management problem, trying to make decisions, trying to develop strategies with the best possible information at hand. And that's really what the intent of the climate risk brain is. So just to show you how this is organized in a simple view here, the idea here is to really support discussions of, is it worth it to think about this issue? Can we do something about this issue? Which are sort of the two key questions underlying any kind of behavioral change, whether personal or corporate. And so what this brain does is organize a huge amount of information into these is it worth it, can we do it questions, 100 different questions. How is climate change linked to other issues like water and national security? What do we really know about climate change? And as you can see, one can dig down into each of these subjects. What don't we really know? And even getting over to the issue sort of climate risk through a business lens, climate change as a business risk, as a business opportunity, communicating corporate climate risk, managing corporate climate risk, which gets down into all sorts of things that companies are doing, and again, a large database of information. And to give you just a little bit of a sense here of what's really here, what I'm going to do is just pop out and show that in each of these different categories, there tends to be a lot of information here and a lot of interesting linkages to different kinds of information. So when you get into this, you can have all sorts of conversations, go down all sorts of interesting paths in talking about climate risk and climate opportunity that normally are very difficult to do. So that's what this climate risk brain is built to accomplish. And if you have other questions about it, I'd love to hear them. Thanks.